Hello, so we are back. And now my question is, do you really love your electronics? Well, you know what I mean? Like real love. Okay? So today video, it's about love. So I'm Dr. Love and let's spend the next 10-15 minutes speaking about what we love, the electronics, okay? So actually we are speaking about our electronics and particularly yes, I will be speaking about my electronics, yeah? Let's do a short experiment, yeah, short one. We have a light bulb, we have a power supply, and we have a bunch of transistors. Now, what I will do, I will take one transistor. I will short base and collector together, and we'll power up the light bulb with this transistor. Okay, so the current is flowing through the transistor. Now, indeed, this transistor is not meant to carry that much current, but we can see how the heat it will affect a transistor. So when the light bulb goes bright, the transistor is shorted, and must be few seconds only. I mean, clearly this transistor is not meant to carry that much power. Now it's getting very hot, very hot. The light goes off, and at some point it will be brighter. Yeah, the transistor is gone. So right now the transistor is shorted. Okay, now let's get another transistor. Wow, proper hot. Now let's get another transistor. We're gonna do the same thing. Those pins together. Now with the light bulb. Okay, all good till now. But now let's add just a little bit of heatsink, okay, over the transistor. Yeah, that's all. That's all. I'll keep the heatsink pressed here because it will take very hot. Now the light bulb is on, you can see, and nothing will happen. I mean, I can keep and hold this here till tomorrow. The transistor it will not get shorted again, just because the transistor can get rid of the heat. Okay, just using a small thermal pad. Maybe it will goes dead, yeah. Maybe it will goes dead because it's out of pressure on the transistor, out of current. It's going through the transistor. But it will take long time just because the transistor can eliminate the heat. Okay, so it's still working a lot longer compared with the other one, and this is a good sign. So the biggest enemy of the electronics is the heat. And wow, that's proper hot. And the easy way, and I really mean the easy way to bring an improvement to your electronics, and I mean with your electronic, if you love your electronics, but especially your tools. I mean, especially my tools. My tools, I want to be sure I can count on them. I want to be sure they are working for years. Yeah, whatever I'm doing here, whatever stupid I'm doing, yeah, I want to be sure I can count on my tools. Okay. Now, what I want to do, I want to share with you. Yeah, well, I want to share because this is kind of obsession. I don't know if it's obsession. Maybe this fear. It's a fear. Fear of the heat comes actually from the experience. Or maybe it's just my obsession. You know, just leave me a comment and tell me if you have those obsessions. Yeah. So any device what I'm using, not any, special my tools. Okay. I will open the device and I will check and I'll see what kind of improvement I can bring, or the way how can I get rid of the heat in the first place. If you think the manufacturer they know what they are doing, and actually yes, they know what they are doing. What they are doing, it's about to work under the warranty time. So any device it will be built just for them to be sure it will work on the warranty time, not more than that. Yeah, not more than that. What can I say? I'm not happy buying something and just to have like to be working for 1 year or 2 years. That doesn't really make me happy. So if a component is working, let's say at 60 degrees, yeah, just lowering the temperature with 10 degrees, actually you double the life of that component. Yeah, and I'm speaking about semiconductors. Now let's see the most common problems on a device and how this can be improved. Okay, let's go. Now let's start. You remember this tool? You remember this? I reviewed it. If you remember. Okay, let me switch. Just tell me if you remember this video, this one. Yeah, if you remember this video. I made this video and I review. Look, I bought this device and I'm using it, but no one asked about the black tape over the device. Anyone notice the black tape? But no one asked, sorry, why this new thing what you are reviewing has a black tape? No one asked about this black tape. It's because soon as this arrived, I tested and I was happy with the results. Yeah, I open it and I tune it up. Yeah, so let's have a look inside. Yeah, this is a nice, nice charger. Okay, and pay attention. Pay attention. What do we have here? Yeah, this is the main switching transistor with the rectifier bridge, a little bit of heatsink. Thermal pads. Yeah, this is the best. Otherwise, you have to use metal, but not metal. This, of course, I don't like the metal, but are great, are fantastic. And here we have the rectifier diodes and another piece of thermal pad. Now I'm pretty sure I opened this one. Yeah, let's open and have a look on the other side. Okay, so we open. Let's have a look on the other side. And you can see, because this doesn't come from factory like that. I mean, you can spot, because this is the main issue. So actually the manufacturer, they are using a lot of components, yeah, are using a lot of components cooling down by the board, okay? But they are not adding extra solder. So the components are cooling down from the solders. And I can see, you can check here, look. Solder, 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 extra solder. Here again, I make sure I solder this. This is a weak spot, you know, where the cable, the power cable is coming. This you always have problems, especially with the sockets which are soldered on the board. So you can see solder, solder, extra solder on the main switching transistor, extra solder on the transformer. Yeah, you can see extra solder on those resistors, especially when you see big resistor on a parallel mode. That's mean a lot of current they are carrying. Extra solder on this diode. That's how you improve your electronics, just making sure the components, it will get cooler. What we did, we just improve the cooling surface, yeah, and the heat is getting dissipated easily. Now let's check another one. Great. Now let's move on the next device. Remember, this is my meter, which I also have on screen. Yeah. I don't think I should open this. I just want to show you. Inside there is a few resistors and I believe a MOSFET, which can sometimes get hot, especially when you carry a lot of current. You see that piece here on the bottom of heatsink? Yeah. So here inside, you have the same thing here. Yeah, that is something like that. Okay, so that's how I try to cool to keep this cool. You can see it from this side also. When I'm charging and I'm carrying a lot of current, I just want to be sure, you know, this is cool and it will have longer life. Now let's go to the next one. Okay, the next one. Do you remember this video when actually I was unboxing the microscope? You should remember this video. But you know what? I haven't seen anyone to ask me, look there, yeah? The seal is void. So check there. Yeah, you can see on the camera, you can see the seal is void. And no one asked, sorry, why a brand new camera, the seal is void? Let's have a look. The seal was void because I opened this camera before the microscope arrived. Yeah, let's open. Of course, I tested before. Of course, I tested the camera before. Then I checked, and inside indeed is a chip is getting very hot. Probably that's the reason why this case is metal. This is my old camera, you remember? I think I bought it from eBay. Yeah, 21 megapixels. And is going up to 2K. So check inside, yeah, check inside. So if you have this camera, okay, I have to put that thing back. If you have this camera, probably the main chip is there, and you can see I put a lot of heatsink under this board. So under this board, actually the chip is on that board with the camera, okay? I put a lot of heatsink just to be sure that chip is cooled down properly. So this video was made 5 years ago, you remember, overclocking a MacBook 5 years ago. And was about how we are using thermal pads, trying to get the heat away and move it to the back cover. So it's not like right now obsession. Let's have a look inside. Ready? Remember that's the laptop we use liquid metal. So check here, that's my laptop. M2 drive. Now this one is supposed to be over the chipset. Keep in mind, even if you have a graphic chip, dedicated graphic chip, this it will be your primary graphics, yeah, the Intel. And here we have some heatsink over the, let me see, over what was that? Oh yeah, those coils, those coils from here. Okay, so that's what you can wow, a lot of dust. Basically that's what you can improve on our laptop. Yeah, just be sure your chipset is cooled down, is sending the heat to the back cover, which is great. The M2 drive, the M2 drive come from the factory. On the back of the M2 drive, you have this kind of thingy, and it's sending the heat to the board, which doesn't really make me happy. I want to be sent away from the board. Back cover, it's a good choice. And then, like, this laptop has a special power supply which is getting very, very hot, so I use some heatsink there. Now the next one is my heat pad. And I'm really happy with this. Yeah, I bought this. I don't think I reviewed it, but it's getting hot very quickly. The same, let's open this. I want to give you a tip if you open this. Yeah, don't do same mistake like me. I mean, don't get me wrong, it's working fine. I don't want to plug the cable now because I'm about to open this. This is a sticker here if you want to open this in the future. Then you have few screws. Okay, just a short tip. Don't do the same mistake like me. I mean, don't get me wrong, nothing wrong happened. But if you open this screw, this is on the corner of the screen, and you can see mine one, just a little bit of piece of glass got broken when I tried to open this screw. So pay attention on this screw. The other one was fine, but this one, yeah. So pay attention on this one. Okay, so check here. Yeah. We have a bunch of heat sinks because here are a lot of components that are getting hot. You see that chip? That is the switching chip. And here I believe we have a MOSFET which is switching between those coils. Here you have few coils. When you switch from phone to tablet, it's actually connecting more heaters. Okay. Also, I have a piece of thermal pad over the transformer, and on the back, look, check here. So every solder from here, you can see I added a lot of solder just to keep everything cool there. Yeah, I believe here is the MOSFET. Here is the switching MOSFET. I believe here is the power supply, the chip, the switching chip from the primary, the high voltage. So that's how I improve this one, just to be sure it will work a long time and I will not have problems. Now you remember this one? Actually, I'm testing the batteries. And inside here are some MOSFETs. They are getting hot. Let's have a look. I remember people asked Sorin, where did you solder the wires? So I soldered the wires exactly on the parallel mode with the first battery, ground, and plus exactly from that current resistor. And here it's a big piece of heatsink, yeah, the thermal pad, which is coming exactly over those MOSFETs and those chips, which they are getting hot when you are testing, especially those resistors. Okay, cool. Now the next in line is my power supply. Okay, let's have a look inside of my power supply. Okay, so that's my power supply. Now my power supply is a linear one, and it's getting very hot just because it's linear. So the original heatsink was this one. Yeah, this is the small one, and that fan was driving me crazy. Okay, so now the fan, right now I connect the fan. I was using one wire from here, and in the serial mode with the fan, and I switch off the fan, and now it's fine. I can keep it with the fan off, and I added this heatsink. You see this big one? I think I bought a while ago, like a audio amplifier from eBay heatsink. So this is the original one. This is what I added over. And here you can see between those heatsink is thermal paste. Okay, so they are very cool most of the time. The fan, I don't even have to start the fan. If I'm using the power supply to charge something, or let's say I need more than 3 amps for a long time, then I will start the fan. But otherwise, this is doing a great job. Now this one is my charger for, this is like a Canon style battery, but the Canon batteries are on many things, like lights, like different camera. Okay, let's have a look inside. Okay, so pay attention here. Here you have those things which are getting hot. You see on the heatsink, and here you have the No, the transistor, switching transistor is here. And the diodes are on the other side. Let's try and open. Okay. So you see those big solders, actually those doesn't come like that from factory. You see, extra solder. Here you have the diodes, the rectifier diodes. Here. Then extra solder on the connector, the transformer extra solder, the optocoupler. Here extra solder. The diodes, they have extra solder. The resistors, which you see on the parallel mode. And a lot of things they have here extra solder. Here the switching transistor from the heatsink, extra solder. If you have this, you know what it is, yeah? This is a Virgin Wi-Fi router. And this is getting mad hot. I mean mad hot. I mean, I believe you can cook on this. So I got this probably like 2-3 years ago. And heatsink. So this metal from here is getting so hot. I believe like, wow, even now it's hot. Probably around 80 degrees. So that one is mad hot. And the construction, like vertical construction, just some pads here, you know, so you can send the heat. Like it's very hot, just to get rid of the heat. Yeah, that's the idea. I mean, yeah, it's, you know what I mean. You know, when the processor is getting very, very hot, like in the summer, it will limit the speed, and you will get latency, like your ping, it will increase. You know that. Okay, so if you really, really love your electronics, try to get rid of the heat. And I told you, keep in mind 2 important aspects. First, the components, they are cooling down using the board, yeah? Add a lot of solder there. And the second, extra heatsink using thermal pads. You can buy those from AliExpress, eBay. Not very cheap. Let's say one like this, probably like £3-4, something like that. But are good because, you know, like in life, if you love something, you will make it feeling better, yeah? So you will make your electronics to feel better. And if the electronic is feeling better, it will have longer life. Okay? So I'll stop now. Hopefully you love your electronics. And not necessarily love, yeah? Maybe you understand something else from love, but, you know, maybe I'm too poor to afford losing a electronic device or a tool. So that's why I'm trying to get rid of the heat, to be sure the life of the electronics will be longer. And don't forget, the heat comes with a price, yeah? And we've seen that before. The heat cracks solders because the components are get bigger, smaller, cold, hot, and you will end up with broken solders. Don't forget this aspect. Okay, so I'll say thank you for watching. Like and subscribe if you like the video, and hopefully you love your electronics, and see you on the next one. Bye.